By writing 3 theta as 2 theta plus theta, show that sine 3 theta is equal to 3 sine theta minus 4 sine cubed theta. So let's do exactly as it says. Let's replace this 3 theta with 2 theta plus theta. I can now use the addition formulae to expand this out. So it'd be sine 2 theta cos theta plus cos 2 theta sine theta. Now, I want to be showing my answer just in terms of theta. I don't want any 2 thetas there. So, let's expand those out. Sine 2 theta, I know is the same thing as 2 sine theta cos theta. So I've just written that in that form. Now the cos 2 theta here, I know there's 3 different ways I can write that. I'm going to write it solely in terms of sine. We want our answer in terms of sine. So I'm going to replace this with a 1 minus 2 sine squared. I know they are the same thing. Let me simplify this a little bit then. So 2 sine theta, cos theta times cos theta is cos squared theta. Then I've got the 1 times sine theta is sine theta, and the 2 sine squared theta times sine theta is 2 sine cubed theta. The only other thing I need to deal with now is this cos squared. Remember, I'm trying to get it so it only has sines in it. But that's fine because I know I can replace this cos squared with 1 minus sine squared. I know cos squared is the same thing as 1 minus sine squared. Which, if I expand that out, I get 2 sine theta minus 2 sine cubed theta plus sine theta minus 2 sine cubed theta, which, if I collect up the like terms, I get 3 sine theta minus 4 sine cubed theta, which is what we needed to show. Aye. Hence, or otherwise, for theta between 0 and pi over 3, we need to solve this equation, given our answers in terms of pi. Well, it says hence, so let's use what we just did in part A. So let's compare my equation with what I did in part A. So we've got this, and I'm comparing it to this. I can see we've got a minus 4 here and a plus 8 here. And we've got a positive 3 here and a minus 6 there. So it looks to me that we're timesing by minus 2. The minus 4 times the minus 2 makes an 8. The 3 times the minus 2 makes the minus 6. So based on that, I can replace all of this with minus 2 sine 3 theta. Which means I can then take that to the other side to get 2 sine 3 theta equals 1. So sine 3 theta is 1/2. If I now do sine inverse, I get pi over 6. Let's draw our sine graph to get the other solution. I only need to actually draw my graph up to pi here. So I've got one solution here at pi over 6. There'll be another solution there. This is pi over 6. This is pi. Take away pi over 6. So pi minus pi over 6 is 5 pi over 6. And then divide both of my answers by 3, and I get pi over 18, or 5 pi over 18. Those are my answers for part II. And then let's move to the part B of this question. Using sine theta minus alpha equals sine theta cos alpha minus cos theta sine alpha, or otherwise, show that sine 15 is equal to 1/4 of root 6 minus root 2. So, sine 15, and I want to use this to help me. So I'm thinking of sine of something minus something to get 15. So two angles that I know, I can take them away and get 15. The obvious ones off the top of my head for me is going to be 60 minus 45. I know 60 minus 45 is 15, and I know what sine 60 is, and I know what sine 45 is, and so on. So I can rewrite this then as sine 60 cos 45 minus cos 60 sine 45. Sine 60 is root 3 over 2. Cos 45 is root 2 over 2. Cos 60 is 1/2. Sine 45 is root 2 over 2. Root 3 times root 2 over 2 times 2. 1 times root 2 over 2 times 2. And if we factorise out the quarter, that gives us the answer that we needed to show.